Okay, and this lesson begins chapter 10, which is triangles. Today we're going to discuss triangles a little bit, and we're going to look at things that probably many of us already know. Um, and we're going to solve some equations. We're going to look at angles and side lengths and perimeter. We're not going to deal with the area today, so that may be a good thing for you. But let's look at a few things we need to know before we get started. Triangles can be classified by their sides or angles. Okay, so let's look at classification by angle measures. We can look at any triangle we're given. If we know the measurements of the angles in the triangle, we can decide if it's an acute triangle, which means all of the angles in the triangle are less than 90, or it may be a right triangle, which means one of the angles is 90 degrees, or it may be an obtuse triangle, which means one of the angles is greater than 90. Okay, so acute, right, or obtuse. Those are the only three choices we have when we classify a triangle by its angle measures. Now, classification by side lengths. We can look at, if we know the measures of the sides, again, we cannot go on how anything looks. We need to know the measures. We can have a scaling triangle, which means all the sides measurements are different. It can be isosceles, which means two of the side lengths are the same, or it can be equilateral, which means all three side lengths are the same. So in classification by side lengths, it can either be scaling, isosceles, or equilateral. Okay, next page. Let's look at a few problems we might run into today as we're doing the worksheet. The perimeter of a scaling triangle is 65 centimeters. That means scaling means here, we're looking at scaling, that means all the sides are different lengths. Okay, the length of the first side is twice the length of the second side. Okay, here is an equation. We see the word is, that's telling us equals, okay? The length of the first side, well, what is that? Who knows? Length of the first side is twice the length of the second side, okay? So whatever we're going to call the length of the first side, we're going to call that 2x. Okay, so the second side we are going to actually call x, and then the first side is, since it's twice the length of that, we'll call it 2x. The length of the third side is 20 centimeters. Now I don't know which one is 20 here. We're going to call this one 20. We will call this one x, and we will call this 2x. Okay, so we're going to add these together, and the perimeter, because the perimeter is, we add the sides together to get the perimeter. We're going to add x, 2x, and 20 together. That should equal 65. Okay, add these together like terms. 3x plus 20 equals 65. Subtract 20 from both sides. This is a very simple equation we should be able to solve. We get 3x equal to 45. So divide by 3, we get x is equal to 15. So this is 15. This is 30 because it's double the length of this, and this is 20. Actually, the 30 should be here. I just put the 20 in the wrong place, but it's okay. This works. 30 plus 15 plus 20 should equal 65, and it does. Okay, next one. The perimeter of an equilateral triangle is 42 centimeters. Oh, got to go back. We forgot something. Centimeters. Got to put units. Okay, even I forget that sometimes. Next. Here we have 42 centimeters. Find the length of each side. Well, each side length is the same. And since we don't know what each side length is, we're going to call it x. And since they're all the same, they're all x. Now, if we add those side lengths together, we should get the perimeter, which is 42 centimeters. Okay, so x plus x plus x is 3x. Then we're going to divide both sides by 3. We should get x equals 14. And it is centimeters. So each side length is 14 centimeters in length. Okay, next problem. Now we're going to look at angles. Did we classify? We don't have to class. Yeah. Okay. Measures of the three interior angles of a triangle add to be 180 degrees. Okay, so all three angles have to add up inside the triangle to be 180. Now let's look at a few problems that deal with finding angle measures. The ratio of the angle measures of a triangle is 1 to 3 to 5. Find the angle measures. Then classify the triangle by its angle measures. Okay, this is the second part. The first part is find the angle measures. This is pretty easy. When you see something like this, 1 to 3 to 5, those three angles, well, 1 we're going to call 1x. 3 we're going to call 3x. And 5 we're going to call 5x. That's 1 to 3 to 5. This is 3 times this. This is 5 times this. They should all equal 180, 180 degrees. Add together, that's 9x equals 180. X must equal 20. Okay, so if x equals 20, that's one of the angles. The other one is going to be 60, and the other one is going to be 100. And all of these add to be 180. Okay, classify it by its angles. Well, we have one angle that's greater than 90, so we're going to call this an obtuse triangle. Okay, here's the first answer. Here's the second answer. It's an obtuse triangle. Next. Ratio angle measures of a triangle is 3 to 5 to 12. Find the angle measures. Okay, so 3 to 5 to 12. Excuse me, didn't mean to do that. That's going to equal 180. Add. We got 17, 18, 19. We got 20. X equals 180. X equals 9. So if x equals 9, let's find the three sides. That's not one of the side lengths. One of the side lengths is 3x, 1 5x, 1 12x. So 3 times 9 is 27. That's the first side length. 5 times 9 is 45. That's the second. 12 times 9 is 108. That's the third. Okay? What kind of triangle is this? Classified by its angle measure. We have one angle over 90 degrees. It is an obtuse triangle. First answer, second answer. Okay, next. Find the value of x, then classify the triangle by its angle measures. Value of x here, we've got 2x, 2x, and 60. They should all equal 180. Okay, so 2x plus 60 equals 180. Add 2x together, we get 4x plus 60 equals 180. Subtract 60 from each side. We get 4x equals 120. Divide both sides by 4. We get x equals 30. So if x equals 30, this has to be 60 degrees, and this has to be this has to be 60 degrees. Now, classify it by its angles. All of the angles are under 90 degrees. This is called an acute triangle. Okay, next one. We've got an 80-degree angle. We've got an angle that's 4x and an angle that's x. All of those should equal 180. Add the x's together, we get 5x plus 80 equals 180. Subtract 80 from both sides, we get 5x equals 100. That means x is equal to 20. So this is 20, and this is 80. Okay, all of the angles are under 90. This is called an acute triangle. Next one, we've got x plus 25, excuse me, plus 25 equals 180. Okay, add the x's together. We get 2x, add the 25's together, plus 50 equals 180. Subtract 50 from each side, 2x equals 130. Divide by 2, x equals 65. Okay, so if this is 65 degrees, this is going to be 65 plus 25, which is 90 degrees. Okay, if it's got 190-degree angle, it is called a right triangle. So we have an acute here, and a right triangle here. That is all for today. That pretty much sums up everything we need to do today.